This is Dr. Moga, and today we're going to be talking about the effect on gas pressure in terms of particles. First of all, we need to know the relationship between pressure and temperature. According to the kinetic theory, gas particles are in constant random motion and exert pressure by colliding with the walls of the container. So we need to know how to calculate it. If I was given a certain pressure, let's say that I started with 20 Pascal and my temperature was 24 degrees Celsius. And they told you that the temperature was increased to 50 degrees Celsius and they required the new pressure. So what am I going to do? I'm just going to put 20 over 24 equals, let's call it P2 over 50, and then do my cross multiplication to get the answer. It's as easy as that, and of course your answer should be in Pascal. Okay, so when temperature increases while volume remains constant, this is very important, the average kinetic energy of gas particles will increase because temperature is directly proportional to kinetic energy. So particles move faster, hit the walls more frequently with more force, leading to a greater force per unit area or higher pressure. Vice versa, when temperature decreases at constant volume, the kinetic energy will decrease, particles will move slower, colliding less frequently with less force, causing less pressure. Okay, what if it's a constant temperature and I change the volume? Now it's the opposite way around. If the temperature is constant and the volume increased, that means I give it more space to move around, the particles will have more space, they will collide less, and therefore pressure will decrease. If I decrease the volume, the particles will have less space to move, so they will hit the container walls more frequently, causing more pressure. So at constant temperature, pressure decrease when volume increase, and pressure increase when volume decrease, vice versa. Here's what we've talked about last session about converting from Kelvin to degrees Celsius, and we said that the absolute zero, which is Kelvin, we called it absolute zero because this is the temperature when particles are not moving. When we want to convert from Kelvin to degrees Celsius, all I have to do is, from small to big, I will add 273. Big to small, I'll subtract 273. Okay? All right. Here's an example. Convert 25 degrees Celsius to Kelvin. We said from small to big, I'll add 273. So from Celsius to Kelvin, I'll add 273. I'll have 298 Kelvin. Here's another one you can try on your own. Pause the video, solve it, and then unpause. Kelvin to Celsius, we said from big to small, we're going to subtract 273. So the answer is going to be, okay, it does not want to. Here we go. So it's going to be 37 degrees Celsius. And that's all for today. Have a good day, and please let me know if you have any questions.